Over the last 6 months, AI has changed in meaningful ways, but not in the way headlines usually suggest. Models have become more capable and more multimodal, working with text, images, audio, and video at once. The real transformation, however, is that AI is moving out of research labs and into real systems, where cost, reliability, and maintainability matter more than flashy demos. New machine learning algorithms continue to appear, but progress today is mostly evolutionary rather than revolutionary. Hybrid approaches, including experiments with quantum computing, show promise in research settings, yet most of these techniques are not ready for production systems that require stability, predictability, and reproducible results. One of the biggest shifts is happening in infrastructure. AI is no longer purely cloud-based. More inference is moving to edge and on-premise systems because network latency, data transfer costs, and privacy regulations make centralized cloud processing less practical for many real-world applications. Generative AI is still improving, but the pace of quality gains has slowed. After the rapid breakthroughs of 2022 and 2023, recent models bring only incremental improvements. Hallucinations, factual errors, and long context reasoning remain unsolved, limiting how safely these systems can be used in critical environments. At the same time, AI is becoming regulated like any other enterprise technology. Requirements for documentation, explainability, and auditing are growing. In practice, this means that a significant part of AI project budgets is now spent not on models, but on compliance, reporting, and governance infrastructure. That shift explains why investment is flowing away from new models and toward infrastructure. MLOps, monitoring, deployment platforms, and synthetic data tools are attracting more capital than foundation models. The market is maturing, and operational efficiency is becoming more important than raw model performance. Explainable AI is no longer optional. In many regulated industries, systems must justify their decisions in a human-readable way. Even though this adds cost and computational overhead, transparency and accountability are now core requirements for deploying AI in real business environments. In vertical sectors such as energy, logistics, and infrastructure management, AI is starting to deliver real, measurable value. Instead of general-purpose chatbots, companies deploy domain-specific models tuned for their data and workflows. What matters most is not having the best model, but having one that works reliably in practice. New developer platforms are changing how AI systems are built. Tools that integrate multimodal inputs, synthetic data, and streaming responses make it easier to move from prototypes to production. Today, these platforms often determine how quickly a company can deploy AI more than the model itself. Synthetic data is becoming a key component of modern AI development. It allows models to be trained and tested without exposing sensitive or rare real-world data. This reduces privacy risks, lowers costs, and makes it possible to simulate scenarios that would be expensive or dangerous to collect in reality. User interfaces for AI are becoming adaptive and context-aware. Systems now adjust their responses based on device, interaction mode, and user behavior. While this improves usability, it also increases the complexity of designing and maintaining these systems at scale. In medicine, AI now matches human experts in specific diagnostic tasks. However, the most advanced technologies, such as quantum-based molecular simulations, remain mostly in research environments. There is still a significant gap between laboratory breakthroughs and everyday clinical practice. Business process automation is one of the most mature AI use cases today. Systems can extract, validate, and integrate data across workflows, reducing manual labor and errors. This is one of the few areas where the return on investment from AI is already clear and measurable. In education, AI increases access to knowledge and enables more personalized learning. At the same time, training in AI itself is becoming widespread, as more professions require understanding how these systems work and where their limitations lie. Despite rapid progress, core challenges remain unresolved. Hallucinations, data bias, energy consumption, and regulatory pressure continue to limit what AI can safely do. The technology is maturing, but it still requires engineering discipline and realistic expectations, not blind faith in marketing promises. Thanks for watching. If this was useful, consider subscribing for more technical, no-hype analysis of AI and technology.